The point is not only obtaining a feasible assignment of tasks to station, and by feasible I mean that it doesn't violate any precedence constraints. Our objective is produce as much as possible, and that means minimizing the cycle time. And that is the way that implicitly we smooth the production. If we minimize the cycle time, it means that we don't have the station working a lot and others working just some time per item, and having that issue I was discussing before. If we reduce the cycle time, we will probably have similar values of the times that I need to use for performing all operations of each and every station. Let's see that. We have here an example of a possible assignment of tasks to stations. So we are performing tasks 1, 2, 3, 6 in station 1, 4, 5, 7 in station 2, 8, 9, 11 and 10 to station 3, and finally only tasks 12 to station 4. This doesn't violate any precedence constraints. You can check that. You have here the information. And we can go a step further and calculate the time that each amplifier is going to stay in each station. Or put it differently, what is the time I have to use to do all the operations in each station so that they can move to the next one and progress along the manufacturing process. So here we have station 1 with tasks 1, 2, 3, 6, and task 1 takes 3 minutes. There we go. Task 2 takes 6 minutes. Task 7 takes takes 7 minutes. This is the 7 we have here. And task 6 takes 8 minutes. So the sum of those 4 durations is 24. That means that every time we start assembling the components that we are going to assemble in station 1, 24 minutes later, that tasks are performed and they can be sent to station 2 to perform these tasks, whose total duration is 19, because it's the sum of the tasks durations of 4, 5 and 7. And the same goes for station 3, where the total time is 30. And finally we have station 4, which just have to employ 3 minutes to do task 12. So you can see that this is a feasible but a very bad solution, because that means that we will have an amplifier produced here every 30 minutes, although we have the station 4 only working 3 minutes per item. So whereas these guys here will be busy all the time, people in station 4 won't be doing pretty much anything, and well, this will be kind of working close to the station 3, and this, well, is not much. It's just like 2/3 of the time of the time that station 3 is using. So it'll be idle like 33% of the time. So this is not a very good solution. Our idea then is to decide how to assign tasks to solutions so that these values are as similar as possible, and that is what you get if you try to reduce the largest value of all. So you're going to try to flatten that values you have and get production as high as possible. You want to have the minimum cycle time according to the assignment.